In this video, you will learn how to solve for the number of moles and grams of some compounds using dimensional analysis. Alright, let's solve this problem here. Anhydrous sodium sulfate can absorb water vapor and be converted to the decahydrate. By how many grams would the mass of a 1 gram sample of the anhydrous compound increase if exposed to enough water to produce the decahydrate? So the first thing we do here is we write the chemical reaction. So we have anhydrous sodium sulfate. Okay, so that would be Na2SO4. It says decahydrate, so plus 10 water, and this would produce Na2SO4, right, decahydrate. So we have 1 mole of sodium sulfate and 10 moles of water here. And we're given 1 gram sample of anhydrous compound. We need to solve for the number of grams of water. So let's start with the given value, which is 1 gram. So 1 gram of anhydrous sulfate, Na2SO4. We need the molar mass of Na2SO4. That would be 2 moles of Na, 1 mole of sulfur, and 4 moles of oxygen. So that is equal to 142.04 grams per mole. Alright, and then we multiply this by 1 mole Na2SO4 divided by 142.04 grams Na2SO4. Then we multiply by the mole ratio. So we have 10 moles of water is to 1 mole of sodium sulfate. And then we multiply this by the molar mass of water. So molar mass of water is 18.02 grams per 1 mole water. Alright, so grams and Na2SO4 cancels out, as well as the moles and mole water. So we are left with grams water, and this would give us 1.27 grams of water. So you just have to multiply 1 times 1 divided by 142.04 times 10 times 18.02, and then you'll get 1.27 grams of water. So 1.27 grams, therefore the mass of a 1 gram sample of anhydrous compound will increase 1.27 grams if it is exposed to enough water to produce the decahydrate. Alright, let's solve another problem. Alright, solve this problem here. How many moles of nitric acid will be produced from the reaction of 53 grams of nitrogen oxide with excess water in the following chemical reaction? So we're given this chemical reaction here. Let's just take a look, check if it's balanced. So we have 3 nitrogen here, 2, 3 nitrogen, oxygen is 6, 7. Okay, 7 water, hydrogen, 2 moles of hydrogen. So it's balanced, and now we can start solving the problem. So we're given here 53.0 grams of NO2. We can start from there. So 53.0 grams of nitrogen dioxide. Right, multiplied by, okay, so we need the molar mass of NO2. So NO2 is 46.0 grams per mole. So this is 1 mole of NO2 over 46.0 grams of NO2. And then, all right, we multiply by the mole ratio of nitric acid and nitrogen dioxide. So that would be 2 moles from here. 2 moles nitric acid is to 3 moles of nitrogen dioxide. And then, all right, so, okay, it's only, right, all right, the grams here cancel out, and as well as the moles NO2, and then we are left with moles nitric acid. So that is what we are asked for, number of moles of nitric acid. So we just multiply 53 times 2 divided by 46 divided by 3 moles, and so we get 0.768 mole nitric acid.